let's start with a bit of, that is quite a famous one, but I don't want to jump the gun yet on that. So let me first, when I talk about a trig identity, all I mean is something that is equivalent, right? So some of the trig identities that we have dealt with already are things like, let me make this a little bit thicker, a little bigger as well. So some of the things that we have dealt with are things like the sine of 180 minus x is equal to the same as, oh, what's going on with my pen, is equal to the same as the sine of x. So that is one type of identity, and that's what we called the reduction formula. So I think we all remember, that from last week or the week before. But then another type of identity we have is a co-ratio identity. So we might say the cos of 90 minus x. Who can remember what the cos of 90 minus x is? Just so while we're going through this revision, that's also a trig identity that we need to kind of familiarize ourselves with. I think that this is, it's not actually zero. This is going to be not the cos even, it's going to be the sine of x. Now, if you're feeling a bit confused about that, that is called a co-ratio identity. And I've done videos previously on that so that you can have a look at. Okay, so this is the reduction formula, and then this is what we call co-ratios. But there are other types of trig identities that we need to know about. And so that's where I'm going to start with today. We're going to move on. And so probably the first one that we need to get familiar with is the fact that the tan of x can be rewritten in terms of an identity where it's sine x over cos x. Now, I'm just making that claim at this stage. I'm not saying why it is, but that is an important identity in trigonometry, that the tan of x is equal to the cos of x. And we often change between these two. The tan of theta is equal to the sine of theta over the cos of theta. Give me a thumbs up if you have seen that trig identity before. The tan of x equals the sine of x over the cos of x. All right. What about Manila or Tondwayo? Sinako, I want some votes from you too. Have you seen this? Yes for a thumbs up, no for a thumbs down. Okay, awesome. So, no, okay, so Sinako, I want you to take note of this because it's going to come up into, I'm going to use it in today's lesson. And then the other one, it's called the square identity, and I'll show you later why this is true. But if you go sine squared x plus cos squared x, that will give you 1. Also a little bit weird, but that is an identity that you need to know. So if you've got sine squared x or sine squared of an angle plus cos squared of an angle, and this can also be rewritten in different ways. So if I bring this across, we can rewrite this as cos squared x equals 1 minus sine squared x. And all that I've done in that case is I've taken the sine squared x, which was on this side, and what happens when I take this to the other side, it just became 1 minus sine squared x. But you can do the same idea with the cos, and you could also say that sine squared x equals 1 minus cos squared x. Now, that is just moving the cos squared x to the other side where it becomes minus. So this is all the same identity, but these are just two different formats. So all we need to do today is we need to learn how to use these two identities, but over here. So I just want to stop and ask, are there any questions or comments? I know that I haven't said why it's true. At the moment, I'm saying it is true. But are there any questions or comments? If there are questions or comments, maybe raise your hand so that I can see them. Otherwise, if there are none, I'm going to carry on. But I just want to give you a chance to ask me to explain anything extra or that type of thing. Okay, fantastic. All right. So if you are curious, because we don't have loads of time today, I'm going to give you a chance to take a screenshot. This is the proof of why, this is the proof of why the sine of theta over the cos of theta is the tan of theta. And all it involves is using the definition of sine of theta as y over r and cos of theta as x over r, and then doing some fraction stuff. And then the other identity that we're going to be focusing on today is that the sine squared theta plus the cos squared theta is equal to 1. And again, all we do is we put them into y's and r's and x and r's, and then we add them together using the idea of a common denominator. But I don't want to spend too much time today, because on that, I basically just want you to take a screenshot that you can come back to it. But I want to spend most of the lesson practicing test type questions. But this is just related. At the very beginning of the section, we spoke about SOHCAHTOA, but you can also replace the O with a Y, the H with an R, and the A with an X. So if we go back to, that's what this is doing. It's saying, look, the sine of theta is just Y over R. And so that's why we have a Y over R over here. So when you've taken a screenshot of this page, just put S in the chat so I know that you've done it, because this explains why the identities are true. Okay, so now let's go to actually using them. So the key word is, oh, let me write this here. Let me zoom in. The key word is to simplify. You will often be given a bunch of trig identities and you have to simplify. Now, I'm going to start with this one. I need to make this simpler. And I would love somebody to give me an idea about what they might change or to make this this is a fraction, but I want to make it simpler. Where would you start? So you can pop your hand up and give me like an idea, or you can put it in the chat. Who has an idea about where would you start simplifying this trig fraction? It's the sine of alpha over the tan of alpha. Remember the two identities that we used so far. Which one do you think might be used here? And where would it be used? Okay, let's go to Buchle. Buchle, what would you start with? Just give us a hint to get going.
So the tan of alpha is an identity.
Okay.
So we can simplify that. We can say the sine of alpha over the sine of alpha over the cos of alpha.
Love it. Love it, love it, love it. Buchle, you have done us a good service here. I'm going to go back to students in our class and say, okay, see if you can go from there and make this simpler. How would we simplify this? Buchle has helped us out there. What do we do when you divide by a fraction? There's something in grade 8 and 9 that you learn. When you divide by a fraction, how can you make dividing by a fraction a bit simpler? Who has some ideas? Spread the knowledge. Share your knowledge with the people of our room. Okay, now there is something called the top and times, or tip and times. So if I take the sine of alpha and I'm dividing by that fraction, I would times by, now what do I have to do? I have to flip the fraction over. So now I'm going to rewrite this as the cos of alpha over the sine of alpha. Okay, now, if that is the case, I can also write this as that over 1. What is my final answer going to be? And I want everyone to use the chat now. What is my final answer going to be for simplifying this fraction? Pop it in the chat. Pop it in the chat. Who can see that signature move that we need to do? Okay, so Narco, you are absolutely correct. This and this can cancel out because anything over itself is 1. And so we are left with the cos of alpha. So let's just go over the strategy. Step 1 was to replace the tan of alpha with this stuff over here. Then it was to change from dividing by a fraction to timesing by a fraction. And then it was canceling. So there were 3 steps that we had to use, and those steps are very, very common in these types of questions. Now, I want you to go by yourself. I want you to try and simplify this trig expression below. We'll call this B. That was A, and we'll call this B. I want you to simplify B using some of the ideas you saw above. And when you have completed that simplification, I want you to say done in the chat. Or if you have a question, I want you to pop your hand up. So welcome to Pila is joining us. Okay, Bukle, do you have a question? Let's go. Oh, Sanako has a question as well. Okay, let's go to Sanako. Do you have a question or comment or some knowledge you're willing to share?
So I have a question, sir.
Okay, go for it.
So after turning the tan into sine theta over cos theta, can we cancel out the cos with the cos of tan theta and then say 1 minus sine theta or 1 minus sine squared theta?
Okay, interesting. Okay, this is what you can do. You can do this. Is that what you were saying?
Yes, sir.
Okay, now what have we got left? Sine of theta times sine of theta. What does that give us?
Isn't it sine squared theta, sir?
Perfect. Yes. Okay, now that is making me feel like it's something I've seen before. What identity is that? 1 minus, didn't we have something like that towards the beginning of the lesson? Maybe I should scroll up and see if I can still see it. Where is it? Okay. Let me write it on the side so that you can see it. Otherwise, it's going to be too hard to see on cell phones. So there is an identity which says that sine squared theta plus cos squared theta equals 1. I think we could use that to simplify. What do we simplify this to? So, Narco, what do you think this ends up being?
So can you please repeat, sir?
So we've got this 1 minus sine squared theta, which you've got. And I want you to try and use this identity to help you simplify it even further.
So can't we make like one of them the subject and take cos? Can't you say cos equals to 1 minus sine squared?
Yes, exactly right. So basically what you want to do is you want to move in that original identity. It actually means that. Can you see how I made it the subject of the formula? And so in my question, the final answer will be cos squared theta. And so look how much simpler that is than what we started with. And the steps we did was we replaced tan, we then cancelled, and then we used the square trig identity to help us. So Sanalka, are you with me? Are we on the same page?
Yes, sir, we are, sir.
Fantastic.
Thank you, sir.
Pleasure. No, that was good. You knew exactly what you were doing. Give me a score out of 10 as to how you felt about that question, because it's getting a bit harder now. 10 is like very good understanding. 0 is nothing. Tell me how you felt about that simplification question, and be honest, because it affects how quickly or what examples I do based on the numbers I see. Okay. So I just want to focus on the fact that you needed to use the identity that the tan of theta, I replaced the tan of theta with the sine of theta over the cos of theta. So that was the one thing I did. Then I canceled, okay? After I canceled, I then had to recognize that there was another identity in town, that 1 minus sine squared theta is the same as cos squared theta. And so this idea is going to come up again and again now. So we're going to do another one, which is quite similar to that one. So what I want you to do, in fact, I want you to try and do number 4 for me. So forget about number 3 for the moment. I want you to try and simplify number 4, bearing in mind that the two identities that are most useful today are tan of theta is the same as sine of theta over cos of theta. So that's the one main idea. And the other identity that is coming up a lot is that one. See if you can use the stuff in blue to help you simplify number 4. And I'm going to give you 2 minutes, and then just say done in the chat when you're done. Yeah. So this is reminding me of, this is reminding me of that squared identity again. So 1 minus cos squared theta should actually be sine squared theta. Now the question is, what goes at the bottom here in the black box? Let me know, what do you think goes in that black box? Yeah, Sanako, let's go to you.
So isn't it cos squared theta?
Perfect. Yes. Can you see how it sort of looks the same, but then is a bit different? Because if you move the sine across, what's left behind is the cos. Okay, Sanako, you smashed that. Now, unfortunately, we're not done yet. What is going to be the next step? Okay. Bukle, let's go to you.
Because that's also an identity, sir. Because if
Yes.
you simplify that, it would become
Yes.
tan squared theta.
Okay, yes. So basically you've got sine of a cos times sine of a cos. So you actually got, you're using the tan, so you get tan squared theta. And that is exactly what you get. Yes. Okay, everyone, we're doing nicely. I want you to try and do number 3 for me next. So I want you to try and simplify number 3, the one that I'm trying to color in green. Give that one a go, and then tell me when you're done with that in the chat. As we see our confidence growing, we'll increase our... Okay, so Nagel, what ideas do you have here? What would you start with? Give us some ideas to where you would start your thinking.
So
For
I'd split the 10 squared theta into sine
Okay.
squared over cos squared theta.
Okay, so you
I
let me just do that for you. So you saying that you rewrite the tan as that. Okay, cool. And what do you do after that?
So I had a question. So I wanted to ask if I could distribute the cos squared theta inside the bracket.
You know what? Yes, that's exactly what I would do. I would distribute it to there, and then I would distribute it to there. And I'm going to give you a bit more time to work on this, but that's exactly what I would do. Yeah,
Okay, thank you, sir.
cool. Bukle, let's go to you. Do you have a question, or do you have some insight that you can share with us?
So because cos squared theta times 1 remains the same,
Okay,
I was
so let me
thinking that
write
we
that.
could just,
Yeah, okay.
so then it would also, because we're distributing to both, so then
Oh,
would not be then cos squared theta multiplied with sine squared theta over cos squared theta,
yeah,
and
so
then
that's
the
what you're doing.
cos's would cancel out.
Yeah, I think that's what happens. And then you get left with just a sine squared theta, hey? Because, yeah, that times 1 stays the same. And then I basically just shared an example there. But now, can you simplify that any further?
You can, it's equal to 1.
Yeah, because actually this is the same. When you add things, the order doesn't matter. And so this is indeed, that whole thing is equal to 1. Okay, so you can see that there's definitely a couple of main ideas that we keep reusing. But yeah, I think that is quite nicely done so far. So for the last one before break time, I want you to try and simplify that expression. So use what you can to simplify the one at the bottom there. I'll call it should we call it number 5, just because. See if you can simplify that, and then we're going to have a break after we've done that one. And just say done in the chat when you are done. And I'll leave those other ones up just as an example. Can you simplify that? Who has an idea to get started? What's really catching me are these tan squared thetas. Does anybody have any ideas? Okay, let us go to Bukle. What would you do?
So we could simplify those functions. We could make them sine squared theta over cos squared theta, the both of them.
But now, what I was thinking, Bukle, is couldn't you also maybe take the tan squared theta out?
You could, because it's a common factor.
Yeah. So what would go inside?
Inside would be cos squared theta times sine squared theta.
Not times, it would be.
Oh, plus cos, yeah, plus sine squared theta.
Okay. I like that. Let's give some more time and see what people can do on that. Okay. What do we think the last thing is now for this? Yeah. Buchle, let's go.
So cos squared theta plus sine squared theta is an identity, so that would be 1.
Yeah. So this would be 1. And so then the final thing would be
Would
tan
still
squared.
be tan squared theta.
Yeah, and that's it. All right, everyone. That is, give me a score out of 10 about how you're feeling. Sanako, let me go to you.
So it's still fine. So if you broke the tan squared theta into sine squared theta over cos squared theta.
You would have got the same answer, yeah, because you actually, you know what? Now that I think about it, did you do this? Okay, so plus. So we have that. Okay, but now here's the problem. So you've got your cos squared, then you've got your sine squared theta over cos squared theta. Did you have this problem?
Yes, sir. That's the problem that I had, sir.
Yeah. So I'm not sure that, can you see everyone why? Because the problem is these two things together make life difficult. So I think you
Yes,
had to pull the tan squared theta out like this.
okay. Thank you, sir.
Yeah. Cool. All right, everyone. I want everyone's cameras on, and I want you to give me a score out of 10 for how you're feeling, and then we're going to continue. Okay, and then let's also stand up and let's do some stretching. Okay, so everyone seems pretty comfortable, so that's good. Let us start with some deep breathing. Yeah, then let's just shake out our arms. Let's just shake out our other arm. Let's shake out our legs. Shake out the other leg. Let's roll our shoulders. Roll our shoulders forward. Put our arms out. Small circles. Change the direction, go backwards. And shake them out one more time. Okay, now let's just get some blood pumping in our bodies. So we're going to jump. We're going to do jumping jacks. We're going to do 15 of them in 3, 2, 1. Let's go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. Then let us go and do a little maths puzzle while we let our brains unwind. So we are going to do a maths 24 puzzle, and you guys are going to tell me you have a choice of 3 of them. Can you, well, let's actually do these 2. Can you make 24 using either of these cards? See if you can do that. Okay, who can give me some help with this? Okay, Bukle, you are on fire today. Share with me your wisdom about this one.
So we're most allowed to use addition, subtraction, multiplication, and division, right?
That's it.
So
Yeah.
I was thinking if that's the case, what we can say is 7 plus 1 minus 5 times 8.
I think Pila and you have got the same thing. So 7 plus 1 is 8. And then
Minus
you
5,
said,
yeah,
so minus 5, which is 3.
times
And
8.
then, which is 24. And Pila said 7 plus 1. Yes, exactly the same. Okay. Both of you get a credit for the red one. Can anyone do the blue one? It's a 7, 6, 2, and 2. Can you make 24? I'll give you a hint for the blue one. Think of 7 plus 6. How could that get to 24? Who has an answer for that one? Okay, I'll give you 30 more seconds and then we're going to go back to our lesson. But I think you've used up these 2. So you've got 13. And then I think I'm about to steal this from someone. But I think the key thing is to go 13 times 2, which is 26. And then take away 2, which gives you 24. Okay, everyone, let's get back to our trig identities. So we are now going to go and have a look at something like this. And this looks rather tasty. So I want some ideas from the class. What would you substitute or replace to start simplifying this question? Where would you start to start simplifying this question? By tan. Okay. Yes. So, Manila, I think that is definitely, what would I, so you would change, oh, yes. Okay. So Manila is saying, I hadn't actually thought about that. So if I replace the tan squared with minus sine squared beta over cos squared beta, what would you do next, Manila? So if I replace that, I think we're on the, I like the look of that because you've got cos squared betas at the bottom. What would we do next? Can anybody else see something we could maybe replace? I was thinking we should probably leave the cos squared beta the same, but maybe this thing on top can be changed. What can that be changed to? Okay, let's go to Sinaco.
So isn't it going to be sine squared beta?
Yep, it's going to be sine squared beta because I'm using that same identity. I don't know why my pen isn't suddenly working. Okay, I'm using my other thing. So this should be sine squared beta. Okay, now what is that going to end up giving me? I think this all is going to be over cos squared beta. But now I need to know what goes on top. What do we think goes in the big black box? Okay. Bukle, let's go to you. What would you put there?
I'm not sure if my thinking on this one is quite correct, but
Go
since
for
we've
it.
already solved for the bracket, it was
Yes.
1 minus cos squared beta, now it's sine squared beta. I think the two signs would just cancel each other out, wouldn't they? Because they're
Yeah.
subtracting with each
And what
other.
do you get there?
0.
Exactly.
So
And what 0 divided by
undefined.
anything? Okay, well, it's actually not undefined. It's just going to be 0. Yeah. Because anything divided
Yeah.
by, if you think about it, anything divided by 0 is just going to be 0. So that simplifies down to that. So that's a bit of a sneaky one, but you're quite right. It's the same thing. So it must be 0. Okay, now let's go to a slightly more sneaky one, but I think you guys are ready for this. So you have to simplify this one. And just to show you what it says sine theta minus sine theta times cos squared theta. So sine theta divided by sine squared theta. So I'll color it in yellow just to give you more contrast. See if you guys can do that one. See if you can do that one. I want to know from the class, where would you start? Okay. I don't like the look of the top one. Can anybody suggest a technique that could maybe help us? We sort of used this earlier on. You have a sign here and a sign here, but you can't subtract them. So if you can't subtract them, what do you think, Manila? What would you do? Or maybe Peter, what were you, Antoine? What do you think? What technique did we use earlier when we couldn't subtract them, but we wanted to do something to the top? What could we do? Sign is in common. Pila, you are on the money. Yes. So I'm going to take Pila's idea and I'm going to say, look, I'm going to take it out and I want you to help me figure out, what do you think goes inside that bracket there? What do you think goes inside that bracket? Well, I know that this part must be 1, but then there's a minus. So this goes back to that technique called factorizing. I think it becomes 1 minus cos squared theta, and that makes me think of something. So Narco, what do you think we should do from this point?
So don't we turn like the 1 minus cos squared theta into sine squared theta?
Yep, that's exactly what I was thinking. So let's go with this. So we've got the sine theta, and then we're going to replace this with sine squared theta. But you know what? I noticed something else. There's a sine squared theta on the bottom, isn't there?
You cross out the sine squared theta with the one at the bottom. So
Yes.
now final answer is going to be sine theta.
Absolutely perfect. Okay, that is fantastic, everyone. Now, what I want to do now is to say, look, I think that is enough trig identities for one night, but I want us to just go over the main ideas. What we seem to always come back to is, can we replace the tan of theta with the sine of theta over the cos of theta? So that was an important idea. Another important one, let me just get rid of this for a second. Another important idea was, whenever we see like 1 minus the square of something, it's normally going to be the other one on the other side. So if we see this situation, 1 minus a square, it's going to normally reduce to the other one of the trig ratios that's involved. Then some other things that we saw, we could see that we would have to divide fractions. So there were some times tonight where we had to divide fractions, and in order to divide fractions, we just tip them, tip and times. Another technique we had to use was to factorize. And then another technique that we used was canceling common factors. Give me a score out of 10, how you feel about those ideas, because those were the main ideas from tonight. They were, can we substitute those two identities? Do you know how to divide fractions by tipping and timesing? And do you know how to factorize a trig expression? And can you cancel common factors? So just give me a score of 10 about how you're feeling so I know what to plan for Wednesday. Because it helps me kind of in my planning, and I'll show you where we're going on Wednesday. So on Wednesday, what we're going to look at is we are going to start to look at questions. We did that one already. We're going to start to look at these questions where, do you know when we take the one side and we have to prove that it's equal to the other side? So in this case, we have to show that normally the harder side, the one in yellow, is equivalent to the one on the right-hand side. Let's say the one in green. And what we're going to use is we're going to use the skills we learned today to work with the left-hand side in this case and make it, so we're going to work with the left-hand side and make it look like the right-hand side. So that is what we're going to do on Wednesday.